Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Rosli, ID student 2019-268662.
My name is Nur Nadira Zulaika binti Muhammad Nazil. My ID is 2019-423-042.
My name is Noris Aina binti Jumadi. My ID is 2019-23-0176.
My name is Putri Nur Shakina binti Nordin. My metric number is 2019218684. We are from Group 6 and today we will conduct an experiment 2 which is free and forced vortex.
Introduction. The equipment used in the experiment in the laboratory is Vortex free and forced vortex, which is designed to produce and measure the characteristic of free and forced vortices. In fluid dynamics, a vortex is defined as a region in fluid in which the flow revolves around the axis line, which may be straight or curved. Vortices may occur spontaneously or be demonstrated in a lab. There are two types of vortices, free vortex and forced vortex. In engineering industrial sector and the real world, the applications of vortex flow can be seen in various areas like in turbine or centrifugal pump, and in natural phenomena like hurricanes and tornadoes. The first one is free vortex, which is formed due to no external force. The degree of rotation is dependent on the initial disturbance. The free vortex motion is flowed through an opening at the bottom of the shallow vessel, where the speed and rate of rotation of the fluid are the greatest near the center. Second is forced vortex, which is formed due to external pressure, which is created by using the rotating plate with the addition of paddle, which is in our experiment we use the chopstick. The speed of the forced vortex is zero at the center and keep increasing proportional to the distance measured from the center. Fluid mass is made to rotate by external source of power, which exerts a constant torque on fluid mass and cause it to rotate with a constant angular velocity.
In fluid dynamics, a vortex is a region in a fluid in which the flow circles around an axis. A vortices can occur naturally or can be produced by force. There are two types, which are free vortices and forced vortices. This is an example of the surface profile for both vortex. Free vortex. In free vortex, there is no external torque or energy required, and it also can be observed in a drain or in the atmosphere of a tornado. When water flows out a vessel through a central hole in the base, it can form a free vortex. In a free cylindrical vortex, the velocity varies inversely with the distance from the center. V equals to K over R. In a steady-state flow condition, Bernoulli equation is applied, so V squared over 2G plus Z equals to constant. We substitute the first equation into the second equation, we can get H equals to H max minus K squared over R squared 2G. The maximum vortex height, H max, and the constant K equals to V dot R. So this is an illustration of the profile of a free vortex surface. Vortex. A forced vortex is caused by external forces on the fluid, and the fluid rotates as a solid body. The force was created by rotating a vessel containing fluid or by paddling in flight. With the forced vortex formation, the angular velocity is constant when water is forced to rotate. Thus, the velocity will be also constant. So V equals to angular velocity dot R. The velocity h is hc, so equals to v squared over 2g. So we substitute the first equation into this equation, we can get hc equals to angular velocity squared dot r squared over 2g. If the horizontal datum passing through the lowest point of the surface profile, the total energy is equal to h equals to h naught plus hc, where h naught is the pressure head at a datum. So we can get h equals to h naught plus angular velocity squared dot r squared over 2g. When r equals to 0, h equals to 0, thus h naught equals to 0, so we can get the equation h equals to angular velocity squared dot r squared over 2g. This is the illustration for the profile of a forced vortex surface.
The objective of this experiment are: first, to demonstrate the free and forced vortex experiment; 2. To compare the surface profile of free and forced vortex; and 3. To investigate the natural phenomena associated with a free vortex.
Nampak ni sikit. Dia. Okay. Nampak tak?
Benda ni dua je.
Ya.
Satu-satu.
Oh. Asal tu satu tu.
Okey ni.
Ya, dua habis. Nampak baris tak?
Next part is result and data. For the free vortex experiment, we are using three different diameter of the outlet water, which is 0.5, 1.0, and 1.5 cm. Diameter of the vortex observed and the height of the water level is as tabulated here. For the diameter of the outlet water 0.5 cm, we observe that there is low speed of circulation and small size of the vortex created. In the other case, when the outlet water diameter 1.5 cm, we observe that fast speed of circulation occur with the big size of the vortex. For the first vortex, we also use the diameter outlet water 0.5 cm, 1.0, and 1.5 cm. The number of the revolution, time taken to complete the revolution, diameter of the vortex, and height of the water level collected from the experiment is tabulated here. This is the graph that shows the surface profile for the free vortex. As we can see, the surface profile for diameter outlet water 1.5 cm is bigger compared to the diameter of the outlet water 0.5 cm. This is the surface profile for force vortex with diameter outlet water 0.5 cm. This is the surface profile for force vortex with diameter outlet water 1.0 cm, and this is the surface profile force vortex diameter outlet water 1.5 cm. However, the surface profile for the force vortex in this experiment is a bit different with the theoretical surface profile for the force vortex. It is because some of the error could occur as we conducting this experiment at home without enough of the equipment.
Discussion. The experiment was conducted first to determine the vortex surface profile of free vortex and force vortex, and second to determine the relationship between the velocity for free vortex and angular velocity for force vortex. For the first experiment, different diameters of orifices were used to observe and study free vortex. Comparison shows that between different orifices show that as the diameter increases, the velocity increases. This causes a drop in elevation since pressure is the same on the free surface. Various diameter of orifices also demonstrate that the larger orifice diameter creates a greater vortex diameter. For the second experiment, a chopstick was used to create force vortex. The slope from the curve of the graph increases as angular velocity increases. The angular velocity of the liquid in a bottle increases as the depth of each pointer at the different vortex radius will also increase, and this is due to formation of semi-parabolic shape of the bottle. In each diameter water outlet, the velocity heat decreases as the vortex diameter decreases. This research enabled engineers to design turbo-machinery and hydraulic structure, such as hydrodynamic apparatus, that have been developed in water treatment plant based on force vortex behavior to separate solid materials from liquid.
In conclusion, the objective of this experiment is to demonstrate the free and force vortex experiment, to compare the surface profile for free and force vortex, and lastly to investigate the natural phenomena associated with free vortex. From this experiment, we can demonstrate the free and force vortex by preparing apparatus consists of transparent plastic bottle. It prepared with different orifice or bottle or panel diameter with a 0.5 cm, 1 cm, and 1.5 cm, and produce free vortices of different size. While during force vortex, by swirling the stick, the vortex started to form. Both surface profile can be observed by plotting the graph D as x-axis and H as y-axis and calculating the water surface profile. Based on the graph, the stream function formed is the force vortex is parabolic in nature. This is because with the increase in angular velocity, the slope of the curve increases, while in free vortex, the stream function form is hyperbolic in nature and slightly varies in which water opener diameter. However, the result was not accurately because of an error which occurred during the experiment and have incomplete of the apparatus due to the condition.